The stability of the alkenes. The stability of the alkenes can be explained by means of the hydrogenation reaction. Alkenes on hydrogenation in the presence of a hydrogen gas over the platinum catalyst, it gives an saturated compound, that is an alkene. It is an exothermic reaction in which the heat is liberated to the system. When we are talking about the alkenes, so alkenes are variable in variations in substitution. Some alkenes are tetra-substituted, tri-substituted, di-substituted, mono-substituted, and simple molecules like ethylene, they are simple hydrogens are there without substitution. So to explain this property, here we are going to taking the example of butene. So isomers of butenes are observed in this graph. The first molecule is 1-butene, the second molecule is 2-butene but cis configuration, and the third molecule is trans 2-butene. So these molecules on hydrogenation gives a alkane. When we draw the energy profile diagram for this one, if you take x-axis as the energy liberation and y-axis as a enthalpy, the 1-butene molecule on hydrogenation gives minus 127 kilojoules per mole. In the similar way, the cis-2-butene on hydrogenation gives minus 120 kilojoules per mole. Similarly, the trans-alkane gives minus 115 kilojoules per mole amount of energy. So what about this reaction tells about? What this reaction tells about? So in this reaction, all the molecules are converted to a simple alkane molecule, that is a butane. But just look at the amount of energy it is liberated. The trans-alkene, which gives very less amount of energy, that is minus 115 kilojoules per mole. The cis-alkene, which gives minus 120 kilojoules per mole. The difference between these two is 5 kilojoules per mole. Similarly, the 1-butene, which gives an energy of minus 127 kilojoules per mole. Means the trans molecule is being a stable molecule, it is producing just minus 115 kilojoules per mole of energy. Means we can, in another words, we can say the word, the trans molecule is stable, that is why it is giving the less amount of energy is liberated. When you are talking about the cis-alkene, it gives somewhat more, means much more amount of energy is liberated for the cis molecule, means more energy is accumulated in the cis-alkene. That is why it is giving in the form of exothermic reaction. When you are talking about the 1-butene, it is gives highest energy among these three molecules, that is minus 127 kilojoules per mole. This reveals about the enthalpy. The enthalpy means the total energy of the simple substitute, lesser substituted molecule. It is much more. It is giving the in the form of energy on hydrogenation. Means in another words, we can say that say this word, as the substitution increases, the stability is also increases. So let us see the general trend. The general trend is the compounds with tetra substituted molecule are highly stable. It gives or it liberates very less amount of energy on hydrogenation than that of the, means tetra substituted alkenes are more stable than tri substituted molecules. So tri substituted means it is substituted by any alkyl groups and one hydrogen. Next is the di-substituted molecule. When we are talking about di-substituted molecules, there are three possibilities are there. One is the the two alkyl groups are attached to the same carbon atom and the remaining carbon atom attached with two hydrogen atoms. So this is more stable than that of the trans, means each carbon having different alkyl group with opposite side, that is a trans configuration. Why this trans configuration is more stable than this is, or why this trans molecule which gives less amount of energy than that of the cis? Okay. For this question we can say the answer, the arrangement is gives the more symmetry, and in the cis molecules what happens, the bulkiness of the R group which causes the steric strain. That is why all trans alkenes are more stable than the cis alkenes. Next we come to the matter of monosubstituted alkenes. It is substituted with one alkyl group with three hydrogens, and the least one is the ethylene molecule which is substituted by 4 hydrogen atoms. Or we can say the word ethylene gives more amount of energy or more exothermic reaction. It gives more excess amount of energy is liberated to the surroundings. This is about the stability of the alkenes. Okay, some alkenes are we cannot study by using the simple hydrogenation reaction. For such a molecules, to understand their stability, a different techniques, heat of combustion or any other method we are going to follow. But for your syllabus, this is enough, isn't it?